5 Solar System Secrets Revealed. Number 1. What worlds are in the Solar System? Exploration of the Solar System began when early skygazers looked up and saw planets in the sky. At first, they considered them deities, but that changed as people began using science to understand the planets. Today, astronomers use spacecraft and ground-based observatories to make discoveries in the solar system that would leave our ancestors' jaws dropping. Let's see what they've found. What are planets? The solar system has 4 rocky planets: Mercury, Venus, Earth, and Mars, 2 gas giants, Jupiter and Saturn, 2 ice giants, Uranus and Neptune, and at least half a dozen confirmed or suspected dwarf planets. Pluto is the largest and most famous of them and was explored by the New Horizons mission in 2015. We say at least, because, by some estimates, many more small worlds that orbit the Sun just as other planets do. Most are beyond the orbit of Neptune, except for Ceres, which is the only dwarf in the inner solar system. The idea of planet has changed radically from the days of the ancients. Astronomers and planetary scientists are debating just what defines a planet, and the current official definition from the International Astronomical Union is not accepted by all scientists. The debate on what planet means continues as planetary scientists find more worlds in our solar system. Number 2. The view from a comet. Did you know that a spacecraft has visited the surface of a comet eye on a long-term mission? The Rosetta probe was designed to orbit of comet 67P Churyumov-Gerasimenko, and send a lander to its surface. The mission arrived in mid-2014, and its first images and data revealed a bilobed chunk of ice and rock described by many scientists as a rubber ducky in space. The comet's surface is very dark and reflects very little light. It is covered with what look like craters, mountain ranges, cracks, smooth areas, and piles of boulders. The comet itself is about the size of a small city, 3.5 x 4 kilometers, 2.2 x 2.5 miles, and takes about 6.5 years to orbit the Sun. As with most other comets, 67P formed early in solar system history. It may have been broken apart and reassembled in past collisions. Strange, crater-like surface units could be from impacts by smaller bodies, or they might be related in some way to the jets that burst out from beneath its darkened surface. The comet's average temperature is about 205 kelvins, -90 F or -68 C. It has little hot spots, which are regions that get warmer as the comet rotates and different parts of the surface are warmed by the Sun. Scientists now know that the comet contains a great deal of water, and have analyzed its other ices, as well. Number 3. Plate tectonics on Europa. In the Arthur C. Clarke story 2010, Odyssey 2, a follow-up to his famous 2001, A Space Odyssey, humans are warned away from the Jupiter moon Europa by saying, "All these worlds are yours, except Europa. Attempt no landings there. Use them together. Use them in peace." He imagined that life existed on this frozen little world. Today, we know Europa has a deep ocean under an icy crust, with a rocky core at its heart. It is constantly squeezed and stretched by Jupiter's strong gravitational pull, and that action heats it up. People speculate about Europa being an abode for life because it has water, warmth, and organic materials, the 3 main requirements for life. And no life has been discovered there yet, but studies of Europa reveal startling secrets about it. One of them is the action of plate tectonics at work there. If this find turns out to be true, it makes Europa the only other world in the solar system, besides Earth, known to have this process. On Earth, plate tectonics pushes the large-scale motions of the upper part of Earth's crust, known as the lithosphere. Plates spread apart, slide side by side, or dive under one another. They carry along the crust, with the oceans and continents. Plate actions form mountains and volcanoes, spur earthquakes, and create new crust at the mid-Atlantic ridge. On Europa, scientists found blocks of ice slide under another one. Some blocks spread apart and allow water to rush up and freeze onto the surface. Others slide against each other. These actions are how Europa moves deep ocean material up to the surface and replaces the older surface with fresh material. Number 4. Mini-moons form and break up in Saturn's F ring. Saturn's rings are one of the most gorgeous sights in the solar system. They are also a place of moon birth and moon death. The outermost ring has bright and dark spots that seem to come and go with great regularity. There were many bright clumps in the ring in 2006, but they decreased in numbers and brightness until there were relatively few in 2008. According to scientists who have studied ring images, including those from the Voyager 2 mission in 1981, these clumps could come from collisions in the rings that alternately form and destroy mini-moons. This action is stirred up every 17 years when the orbit of the tiny moon Prometheus aligns with the F-ring. They've also seen moon-forming action near the A-ring. As this bumper car action takes place, the material in the ring sticks together to make the mini-moons, or collides to break them apart. It seems very similar to the planet-forming events that happened early in our solar system's history, some 4.5 billion years ago. Collisions and breakups were common back then, as the infant solar system's materials orbited the newborn sun. Number 5. Underground rivers on Titan. Saturn's largest moon, Titan, continues to give up more of its secrets via the Cassini spacecraft. It has hydrocarbon lakes and seas on its surface, and methane rains. Hydrocarbons are complex compounds made of carbon and hydrogen. Astronomers think that Titan is very much like early Earth, and there are questions about whether this moon could support life. The crust of Titan is riddled with layers of icy materials called clathrates. Think of them as icy cages of one material that encloses a small amount of another compound. They are part of aquifers that help trap the runoff coming from Titan's rainy skies. As the methane rain runs under the surface, it interacts with the clathrates, and changes the chemical composition of the rain runoff. Ultimately, this leads to the formation of underground reservoirs of propane and ethane that feed into surface lakes and rivers. This same process occurs on Earth. Water rains out of the skies. It lands on the ground and some of it flows underground, where it is trapped in aquifers of porous rock. As the Cassini mission continues to study Titan, planetary scientists will gather more information about how Titan changes over time, and how the surface and underground systems communicate with each other.